Welcome back, class. Today's topic is very important for the board examination, Ohm's law. And this Ohm's law is similar to class 10th Ohm's law, because in class 10th you simply derived the relation between the voltage and the current. And there you found the V is equal to I into R, and there the R is proportionality constant, right now. That is why there is no clarification regarding how this R is coming and what are the factors which is responsible for the resistance. So only you have found the overview. Today we are interested to investigate the factors of the electric resistance also. So when you derive the Ohm's law with the help of the drift velocity, then you will find some factors which is responsible for the electrical resistance. So let's see, if initially this conductor is not connected with the cell, then the free electrons will move in a random direction, right now, in random direction. But because of that movement of the free electron, there is no net current, because the net velocity of the free electrons is zero. That means mathematically you can write, if we are assuming the initial velocity of the free electron is u1, u2, u3 and so on un, then the u1 plus u2 plus dot 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 plus un, right now, what is that? It is the vector sum of all the velocity. You will get it is equals to 0, right now. This value will be 0, because the net movement of the free electron initially is 0. That is why they are not causing any current across the conductor, although the electrons are moving. But because of that movement, there is no current is flowing, because the net current is 0, right now. That means if the 5 electron is moving this side, then 5 electron is also moving this side. So if you take the vector sum, that will cancel out, right now. That is why the net current the net velocity of the free electron initially is 0, right now. But if you connect this conductor with the cell, then because of that potential difference across the conductor, the electric field is set up, and that electric field is forcing the electron to move in a certain direction. So because of that movement, the external cause, now there is a net velocity across the conductor, and that net velocity causing a current, right now. So today we are going to derive the Ohm's law with the help of this concept. So initially the net velocity of the free electron is 0. When you apply this one, so because of that one, there is a force experienced by the free electron. So what is the value of the force? Force experienced by free electrons is equals to Q into E, right? F is equal to Q into E, but here I am assuming the electron, so this is the value of E into E, right? Because this is the force experienced by an electron is E into E. From the same formula, F is equal to Q into E. So because of that force, what is the accelerations produced? So the acceleration of free electrons is A is equal to how much? E upon m, where m is what? M is the mass of the electron, right now. Here m is the mass of the electron. So I am assuming this is the equation number 1. So this is the acceleration experienced by all the free electrons, right now. So because of the potential difference, electric field is set up, and that electric field is applying this force E into E, and because of that force, the acceleration achieved by the electron is E upon m, right now. This is the acceleration. Now because of that acceleration, the velocities get changed, right now. So the final velocities of free electrons are, right now, I am assuming it is V1, V2, V3 and so on Vn, right now. I am assuming n free electrons are there. So because of that acceleration, the final velocities of the electrons become v1, v2, v3 and vn. Right now, so already we have the acceleration. So because of that acceleration, the velocity gets changed. So the final velocity, after a certain time or unit time, the velocity become v1, v2, v3 and vn. Right now. So what is the definition of the drift velocity? What is the definition of the drift velocity? So definition of the drift velocity is the average velocity attained by the free electrons when the potential difference applied. Right now. So according to definition of the drift velocity, the Vd is equal to how much? The average velocity. So average velocity of what? These 5 velocities. Right now, because these are the velocity after application of the potential difference. So Vd is equal to how much? V1 plus V2 plus plus Vn divided by n, because we have to take the average velocity. So here the number of items are, we are considering n, that is why you will take the division by n. Right? Simple, the average. Right? So put the value of the V1, V2 here. So I am writing this acceleration this side. A is equal to E divided by m. Right? And this is our equation of the. So we have to take the average velocity of the free electrons. Now just put the value of V1. What you will get the V1? So we have the motion equation. V is equal to U plus AT. Right? Simple, V is equal to U plus AT. So V1 is equal to how much? The initial velocity of the first electron we are considering U1. So U1 plus A tau 1. I am considering the relaxation time of the electron. First electron is tau 1. Similarly, for the V2 is U2 plus A tau 2 plus dot. For Vn, it is Un plus A tau 10. Clear? And divided by n. Simple. In place of V1, V2, V3, simple, with the help of the motion equation, V is equal to U plus AT. I just put the value. Right now, don't be confused. Simple. Initially, when the potential difference is not applied, I am considering the velocities of the electron is U1, U2, U3 and Un. Right now, and after the application of the potential difference, because of that acceleration, the velocity gets changed, and the final velocities we are assuming it is V1, V2, V3 up to Vn. Right now, so that according to definition of the drift velocity, Vd is equal to the average of the velocity gained by the electrons due to the application of the electron. So I am taking the average of the final velocity, right? So I am rearranging the terms. So I am taking the U1, U2 plus dot plus Un in this one bracket divided by n, right now, and plus A is common, and here tau 1 plus tau 2 plus dot plus tau n divided by n. Simple, I am rearranging the terms. Right now, U1, U2, U3, Un I am taking outside, and because it is average divided by n, and A tau 1 plus A tau 2 plus A tau 3, like this one, A tau 1, take the A common, in the bracket you will get tau 1 plus tau 2 plus tau 3 and tau 1 divided by n. Clear? Now to see this, U1 plus U2 plus U3 dot plus Un is how much? 0. So this value will be 0. Right? Because the net initial velocity when the potential difference is not applied is 0. That is why it is not casting a current. So here you will get 0 plus A into, and I am assuming the average relaxation time. These are the individual, because the matter is same. So the nature of the electron is also likely similar right now. So individual relaxation times I am taking the average is the average relaxation time is tau. Okay. So the average relaxation time is, I am considering is tau, because the conductor has the same amount of the packaging. That is why this tau 1, tau 2, tau 3 is not very close values. That is why I am taking the average of the value, which is the average relaxation time, which is tau. Right? So 0 plus A tau. Now this Vd is equal to A into tau. Clear? So I am putting the value of this A here. Right now I am putting this value of the A here. So what you will get? You will get EE divided by M. This is the value of the value of A and tau. So Vd is equal to E into E divided by M into tau. Clear? So I am erasing this one. We just note down. So how much will we get? Vd is equal to E upon M into tau by putting the value of acceleration. Now let's see here. This E, electric field, can be represented in terms of the potential gradient. Right now, from the formula, how much? E is equal to minus dV upon dx. Right now, so I am assuming the length of the conductor is L. Right, length of the conductor is L. So here, and the potential difference applied across the conductor is V. So we can write E is equal to V by L. Right now, and again the minus sign only indicates in the direction of the electric field the potential decreases. Right now, already I am taking the potential difference. Right now, E is equal to V by L because the length of the conductor I am assuming is L. Right now, so this is the relation of the potential gradient, or the relation between the electric field and the potential difference. So the electric field can be related with the potential difference. E is equal to V by L. So put the value of here, V here in terms of, so you will get Vd is equal to E by M into tau in terms of E. In place of E, you will write V by L. Okay? In place of E, I have written V by L. Right? So I am also erasing this one. Now, what is the relation between the electric current and the drift velocity? So we know that I is equal to NEA Vd. Right? So Vd is equal to what? I upon NEA. So I am putting this value of Vd from this relation, I upon NEA divided by NEA. Right? So Vd is equal to I divided by NEA. So in place of Vd, I have written this one is equals to E divided by M into tau V by L. Clear? So you see here, after simplification, what we will get. So our aim is to find the V by I, because from Ohm's law we know that V is equal to I into R, or V by I is equal to R for the constant. So I am finding the V by I. So V by I is equals to, so V here, I this side. So that will go this side, on this side. So you will get M upon N E square A. Right now, and this E will multiply E square A, and M upon N E square A. So this is the value of N tau. Right now, M upon N E square tau is, here you will get L in the, right now, or V upon I is equals to N upon N E square tau, N E square tau into L by A. Right now, and V by I is what? V by I is R. R is equal to M upon N E square tau L by A. Right now, just see these two relations. V by I is equals to M. What is M? The mass of electron, which is constant, and the free electron density. For certain material, it is fixed. So N is also constant. The value of E, already the constant, 1.6 into 10 minus 19 coulomb. Tau, the average relaxation time. So because of certain material, the packaging is same. So the time taken by the successive collision is also fixed. So for a certain temperature, this value of the tau is also fixed. Like that. And L, length of the conductor for a given conductor is fixed, and A is also fixed. So here you can see that V upon I is what? Constant. V upon I is constant. So this is our what? This is our Ohm's law. Right now, V upon I is constant, or V is directly proportional to the current. So this is our Ohm's law derivation. So if in the question it is asked to derive the Ohm's law, simple, you will leave the derivation here, right now. But V by I is equal to what? Ohm's resistance, right now. V by I is resistance. So in place of V by I, we can write the resistance R. So R is equal to what? M upon N E square tau into L by A. If you compare this relation by R is equal to rho L by A, where rho is what? Where rho is the specific resistance of the conductor or the resistivity. So you just compare here. So L by A is same. So in place of rho, what is the term? M upon N E square tau. Right? So here we just find, in class 10th you only studied the rho is basically the what? The proportionality constant, and this is fixed for a certain material. But here you found the value of the rho depends upon the mass of the electron and the free electron density, E, the value of the charge possessed by an electron, and tau, the average relaxation time of a conductor. Right now, that is why we are saying for a given temperature. For a given temperature, the value of the tau and n is fixed. Right now, that is why we are saying the temperature is also a factor to change the resistance of a conductor, because if you are changing the temperature of a conductor, the value of the n and tau both get changed. Right now, n is also changing because of if you are increasing the temperature, so the more energy gained by the electrons, and that becomes the free electrons. Right now, so those electrons are lightly bounded. They get the energy from the thermal agitation and start to perform the conduction. Right now, so because of the temperature rise, the value of the n is also changing, and the tau is also changing, because if the temperature increased, that means the energy received by the electron is also increased. That means the velocity of the electron increased. So if their velocity increased, that means their collision is also start to take very quickly. So because of that collision, the relaxation time will decrease. Right now, relaxation time will decrease. So that will decrease the relaxation time. So because of the decrease of the relaxation time, the rho will increase. So very important question, you should note down. So this is the derivation of the Ohm's law, and after that, from this relation, very important conclusion: effect of temperature on resistance for a conductor. Right now, for a conductor, so I am going to investigate if the temperature of a conductor increase, then what is the effect on the resistance. So if you see this relation, rho is equal to m upon n e square tau. So rho is what? Directly related to resistance. So if we increase the temperature, which parameter is going to be changed? The tau. The tau will change, because for a conductor, the n will not increase because of the very small change of the temperature, because the electrons are in the outer cell is lightly bounded, but the next cell, the electrons are very tightly bounded in the conductor. So they need very high amount of energy. So if we are changing for a certain limit, if we increase the temperature, so this n is not going to change for a very high value. Right now, so this n is approximately constant. Right now, if you are not changing the temperature for a very high extent, right now, very high extent. So there is a limit for the increase of the temperature. So if you are increasing the temperature, this tau will decrease. How this average relaxation time will decrease? Because by increasing the temperature, the free electrons will receive the more energy from the surrounding, from the thermal agitation, and because of that energy, their velocity will increase. Right now, if their velocity will increase, that means they will collide quickly, and if they will collide quickly, then their average relaxation time will decrease. So if tau will decrease, then rho will increase. Right now, rho will increase. So that means for a conductor, if temperature increases, right now, if temperature increases, then resistance is also increases. Right? So if the temperature will increase, then average relaxation time will decrease, and average relaxation time will decrease, then rho will increase, and R is directly proportional to the rho. If rho will increase, then R will increase. So here is the conclusion. If we increase the temperature of a conductor, then its resistance will increase. Right? Now just see for semiconductor. For semiconductor. Right? For semiconductor. So for semiconductor case, you know that in semiconductor, the covalent bond with the neighboring atoms, right now, because of mostly the semiconductors have the outer shell, the 4 electrons, and for the to complete the octane, they are making the covalent bonds. So there is a sharing of the electron. So if we increase the temperature, so because of that thermal agitation, the bonds get break, and if the bond get break, that means you will get the more free electrons. Right now, if you get the more free electrons, in that case, that means this N will increase. Right now, this N will increase, that means rho will decrease. Right now, if rho will decrease, that means R will decrease. Right now, so here for semiconductor, if temperature increases, then resistance decreases. Right? Then resistance decreases. Right? So for a conductor, if you increase the temperature, then resistance will increase. Right now, if you increase the temperature, then resistance is also increased. And for the semiconductor, if you increase the temperature, then resistance decreases. Right now, I have given the reason for that. So if you have any doubt, you should mention in the comment section.